Greetings, welcome to another Learning Masters video. Today we'll be talking about mastering tangents and an application of what we're going to talk about here applies to if you're doing Cambridge syllabus, CAPS curriculum, or IEB, and possibly other curricula as well. So I want to give you a breakdown of three things to recall about tangent lines and then work through one Cambridge level exam question for this video. So a tangent is a line that touches a curve at one point, curve being a graph of some point. Okay, so like you can see in this picture, there's a blue graph which represents a curve. It could be a parabola, it could be an exponential graph, for example. So a tangent is a line that touches a curve at one point. Now, there's three important things to remember when you're solving tangent related problems. So I made this poster to help students or to help you to remember the three important things about tangents. So the first thing to note is that the point where a tangent and a curve meet is called a point of intersection. It's called a point of tangency, and it is a point of intersection. So you must remember that in maths, and this applies to any curves or any graphs, when any two graphs or curves meet or lines meet, to find the coordinates of that point, which is called a point of intersection, you always set the equation of the one graph equal to the equation of the other, and then you solve for x. So you put the graphs equations in standard form, y equals to y equals to, then you set the two y formulas equal to each other, then you solve for x. Once you have x, substitute into either one of the formulas, either equation 1 or equation 2, to find the y. That gives you the coordinates of the turning point. So that's the first thing to remember about tangents, that the point of the point of tangency, which is where the tangent meets a curve, is a point of intersection. Okay, now the second thing to recall about tangents is that now there's a connection. This is calculus. Okay, so if you haven't done calculus yet, this part you will not be able to comprehend. So now, where the curve, the slope of a graph or a curve is known as the derivative or the gradient. Now, if we have a graph called f of x or a curve called f of x, and then it touches the tangent at a point where the x value is equal to a, then obviously you can find the y value of the a point of tangency by taking the x value, which is a, and substituting it into the graph of f. That's what f bracket a means. It's a value, it's a y value of the x value a. So in other words, f bracket a means the y value that you get when you substitute x equals a into the formula for f, which is not shown in this case. The formula is not shown, but you need to know that it's just a math way of saying f bracket a or f of a means it's a y value that comes from the x value a. Okay, so where does this fit in with the tangent? So if you can work out the derivative of a curve f, df dx, that means the derivative, and then you substitute the x value of the point of tangency, the output, which will be a number, is the value of the gradient of the tangent line. Let me repeat that slowly. When you take the derivative of the curve, in this case a curve is f, which is a parabola, I differentiate that, and then I substitute the x value of the tangent line. Okay, then the output value is the gradient of the tangent line. That's the second thing to remember about the tangent, is that the derivative of the curve at the x value of the point of tangency gives you the gradient of the tangent line. So you find the derivative of the curve f, and then you substitute the x value of the point of tangency. The output will be a number, which is the gradient of the tangent. Okay, perfect. Last thing to remember about the tangent, it's related to something. If you're doing CAPS or IB, you might have learned something called nature of roots. If you did Cambridge, you might have spoke more about the discriminant. The discriminant is b squared minus 4ac, and it describes the number of solutions or roots to an equation. So a tangent touches a curve at one point only. So this connects to number one. When I find when I'm working with the tangent, the discriminant is always going to be zero. In other words, b squared minus 4ac equals zero. And how do I use the discriminant? So what you typically do, you sometimes you can do step one, which is equate the two curves and rearrange it and get a quadratic equal to zero. Then once you get your quadratic equal to zero, you can use the discriminant. Then you set the discriminant equal to zero, and then you can use that to solve a problem. That's what we're going to be doing in this exam question today. So let's have a look through it quickly. I'm going to stop sharing this, and I'm going to reshare the question that we will do here quickly with the exam questions. So let me just share it. Okay, so here's an example question that is an application of tangents. That's going to apply everything we've just spoken about. The equation of a curve is y equals, so it's a little bit of a misprint, but it should say y equals 2k minus 3x squared minus kx minus k minus 2, where k is a constant. So in other words, k represents a number. And the line y equals 3x minus 4 is a tangent to the curve. Find the value of k. So if you look at this equation, it might look intimidating, but it's really an equation of a parabola because it's in this form. It's a quadratic form. It's got a coefficient in x squared, a coefficient in x, and a constant. Right. So when they gave the equation of the curve and they gave you the tangent line, then they say find the value of k. What did we say? The first connection is to know that whenever a tangent and the curve meet, there's a point of tangency, which is a point of intersection. What did we say we do with the point of intersection? You said equation 2 equals to equation 1. By the way, I forgot to say this. I suggest that you pause the video at this moment and try this question out on your own. And then after you're done, continue playing the video to see and compare your solution to mine. Okay, as I was saying, when the tangent, there's a point of tangency, which is a point of intersection, which is where the curve and the tangent line meet. So we're going to apply the approach equation 1 equals equation 2. So you can think of this as equation 1 and think of this as equation 2. So equation 1 equals to equation 2. So we get 2k minus 3x squared minus kx minus k minus 2 is equal to 3x minus 4. Now I'm going to put this in a standard quadratic form by taking the 3x to the other side and taking the minus 4 to the other side. So this x is going to join with the other x term. The minus 4 is going to combine with the constant. So the x squared term is going to remain unchanged. 2k minus 3x squared. Now I had minus kx. Now the 3 came over, it's now minus 3x. And then add minus k minus 2. And now the 4 went over, so it changed sign to plus 4. All of that is equal to 0. Now I'm just going to neaten this up a little bit. So to put it in a standard quadratic form again, and I will need to actually distribute the negative into the k and to the minus 2 and then combine. So the squared term is 2k minus 3x squared. And then I'm going to put these together. I'm going to say plus, and then these I'm going to almost like factorize. It's going to be minus 3 minus k. That's now the coefficient of x. And then distribute the negative here. Negative times k, negative times negative 2. That's going to give us the constant. I'm going to say plus, and I'm going to put the constant in one bracket. So it's going to be minus k. Negative times k is minus k. Negative times negative 2 is positive 2. And then I have this plus 4, which then gives me the final quadratic form 2k minus 3x squared plus minus 3 minus k times x, and then plus 4 plus 2 is 6, so this is minus k plus 6 equals 0. Right, let me just block this out a little bit. Okay, so this is the equation we have so far. And now, once you've set up your equation in this way, okay, you are now ready to um take this equation and use a discriminant. So we've applied step one of what we learned about, or one of the techniques for dealing with the tangent, which is said point of tangency, so which is a point of intersection. So you equate equation one and equation two. Then we set it up as a standard quadratic equation. Now to find k, we will then use our discriminant. So this is what we have: 2k 2k minus 3x squared plus negative 3 minus kx plus negative k plus 6 equals 0. Now, what the next thing to do here to find the value of k, we just need to apply the discriminant to this. So I'm going to rewrite it on a clean page. Perhaps I will go back to the previous page. Just going to make this a bit smaller and then go back to the previous page. A bit of a glitch here. Okay. Let's go back to the previous page. So this is how far we've got. All it means, I'm going to take what we've done as a result, and I'm going to just do it at the top because I'm running out of board space here. And I've got other work on the other page. So I'm just going to continue. So this is a quadratic equation. This represents a quadratic because it's in the form ax squared plus bx plus c equals 0. Now I can apply my discriminant. For the tangent, the discriminant, which is b squared minus 4ac, that is equal to 0. So what is our b value? Our b value is a coefficient of x. That's minus 3 minus k squared minus 4. The a value is a coefficient of x squared. It's 2k minus 3. And the c value is the constant, which is minus k plus c. All of this is equal to 0. Then this is the equation we solve for k, and then we'll be done. So I'm going to square. I'm disliking the double equal sign, so I'm going to just get rid of that. So I'm going to simplify this. I'm going to square a binomial. When you square a binomial, the shortcut is to square the first term. So take negative 3 and you square it, you get 9. Then you square the last term, take negative k and you square it, you get positive k squared. To get the middle term times these together, multiply by 2. Negative 3 times negative k is 3k times by 2 is positive 6k. Okay, now I then here, what I'm going to do is I'm going to actually distribute the negative 4 into that first bracket. So I'm going to say plus because I'm distinguishing this term from that second term. So I'm going to distribute the negative 4 into the first bracket. That's going to be minus 8k. Negative 4 times negative 3, that's positive 12. And then minus k plus 6. So then from there, I will continue and simplify this further. So I'm going to have to use FOIL here. Firsts, outers, inners, lasts. Since I already had this, so you've written that down, I'm going to have to continue. I'm just going to do it in another color so it's distinguishable. 9 plus 6k plus k squared. Firsts, I'm going to get a negative 8k times 8 minus 8k is going to be positive 8k squared. Okay, then I have negative 8k times positive 6. That's going to be minus 48k. Minus 48k. And then 12 times minus k, that's minus 12k. 12 times 6, that's positive 72. All of that is equal to 0. Collect all the like terms. The k squared together. K squared plus 8 squared, 8k squared. K squared plus 8k squared is 9. K squared. All the k terms. 6k minus 48k minus 12k. That's going to be minus 54k. And then 9 plus 72. That's 81 equal to 0. All three of these terms are divisible by 9. I can pull out 9 as a common factor. 9 times k squared minus 6k plus 9 is equal to 0. Then you can actually think of it as you divide both sides by 9. If you divide both sides by 9, remember you can divide 0 by 9. You just can't divide 9 by 0. Two different things. So then it's k squared minus 6k plus 9 equals 0. I need to solve this quadratic by factoring it. Of course, I will then get k minus 3 and then k minus 3 equals 0. This, of course, leads to, you can think of it as k minus 3 squared equals 0, but it's basically one solution of k is equal to 3. And that would be the final answer. Look at carefully. The question said find the value of k, which means k can only be one value. It's not values, it's value of k. So let's go back to what we started with. We set the two equations of the graph equal to each other, set it up in standard quadratic form equal to 0. Then we use a discriminant from that standard quadratic form, b squared minus 4ac equal to 0. That's a case for a tangent. Then we solve that for k, and then we are done. I hope this video was helpful for you. If you need to pause and rewatch the video again, that would be great. Please do contact us at Learning Masters for more helpful tutoring, Cambridge IEB, CAPS, first year, second year, advanced calculus, linear algebra, A levels, AS levels, Pearson, EdXL, GCSE, IGCSE, you name it. We're here to help you with your math problems. Contact us at 071 400 9965. So that's our number, 071 400 9965. Thank you so much. Have a great day further. See you next time.